Good morning. Mr. Herman here with our first set of notes in Unit 4. Unit 4 is about quadratics, a new type of function we're going to take a look at. But before we get dug into some of these quadratics, we do need to do some review of terms that we've seen before. So today we're going to focus on key features from tables. So this is a good review, a good way to start off the quarter. But we're going to start off with some terms. So we're going to take these terms from a table perspective because we'll look at graphs and equations later this week. So for the maximum from a table, we want to look for the highest y value. Okay, now that means you have to make sure that you always give an x comma y. Okay, so you need to give me a point. Okay, so first off, we're always going to look in that y column, but we always have to give the ordered pair, that x comma y, because I know, okay, that's the biggest value, but where's it happening? What's that x value? Okay, so now likewise, that means the minimum is then the lowest y value, but once again, always give x comma y. Okay, our x-intercept is the y value, or rather the x value, when y equals 0 in our table. And then our y-intercept is the y value when x equals 0. Okay, so we're probably more used to seeing x-intercepts and y-intercepts on graphs, and we'll look at those later this week on Wednesday and Thursday. But just in a table, x-intercept, when is y equals 0? Y-intercept, when does x equal 0? So let's take a look at some examples here of identifying our key features from a table. So we'll start off with our maximum in this table here. So my maximum, I'm going to look for my biggest y value. Okay, so here's my biggest y value. I'm going to go and circle that in green, and I'm going to put down an ordered pair, 0, 1. All right. Now I'm going to do my minimum. So my minimum is I'm going to look for my y value. That is my smallest y value. Okay. Negative 10 is my smallest y value. It's the most negative. Okay, we'll get that going to focus a bit. And then I'm going to write that down at ordered pair, 4, negative 10. I'm not just going to say 1 and negative 10. I'm going to say 0, 1 and 4, negative 10. Okay, so now we're going to look for our x-intercepts. I'm going to do a little highlighting here. Okay, so our x-intercepts are where our y equals 0. Okay, so I'm looking at my y column. Okay, y is 0 here. There's my x-intercept. Okay, so my x-intercept then is 6, 0. And then my y-intercept is going to be when my x equals 0. And that's going to be up here. X column, look at, there's 0. And there's my y-intercept. So my y-intercept is 0, 1. Okay? So we're going to take a look at our table here. I want you to go ahead and try to identify these four things: maximum, minimum, x-intercept, and y-intercepts on your own. And then we will go over it. Okay, so you just answered, found the maximum, minimum, x-intercepts, and y-intercepts of our table here. So let's go ahead and check those and explain why the correct answers are correct here. Okay, so for our maximum, look for my y values. What's the highest one? So you got 8, 0, negative 1, 0, 15. 15 is my biggest y value. I'm going to go and circle that and put down the whole ordered pair. Okay, I want to put down that whole ordered pair, 4, 15. Let's look for our minimum. My lowest y value. I've got 8, 0, negative 1, 0. Negative 1's the smallest value there. So 0, negative 1. Now let's look for our x-intercepts. Okay, so x-intercepts are when y equals 0. So let's look at our y column. There's y 0. There's y 0. We've got 2 x-intercepts here. So we need to make sure that we put down 2 x-intercepts. So we've got negative 1, 0, and we have 1, 0. Okay, so we do need to make sure we have 2 x-intercepts if there's y equals 0 twice. Now our y-intercept will only have one of those. When we look in our x column, oh, there's x equals 0. So 0, comma, -1 is going to be our y-intercept. Okay? So hopefully that makes sense there. Identify maximum, minimum, x-intercepts, y-intercepts. Hopefully it's a bit of a review. All right, so let's go ahead and go onto the back, and we're going to look at our first and second differences. So we want to first check to make sure that the gap between our x values is constant. Okay, so every time I'm doing my x values, it goes like +1, +1, +1, +1, or down here it goes +2, +2, +2, +2. Okay, so looking for that constant gap between x values. Okay. Now, when we're doing finding the differences, we take the second y value minus the first y value. Okay. So we'll take a look at what that means in a second. We'll do an example here. So for our first difference here, I want to do my y, we're only doing my y values. So my first difference is going to be 8 minus 5. And that's going to give me 3. So I took my second y value minus my first one. Now let's go down here. 11 minus 8. Okay, 11 minus 8 is going to give me 3. Do 14 minus 11 is 3. 17 minus 14 is 3. Okay, so that's all we're doing there. Now our second difference, same idea. I want to do 3 minus 3 is 0. 3 minus 3 is 0. 3 minus 3 is 0. You might say, Mr. Herman, that's stupid. It's the same thing. Okay, well, we've seen before if that first difference is the same, it's a special type of function. What type of function is that if we have the first difference that's the same? Hopefully you said linear. Okay, so if we're describing our pattern here, we can just say that the first difference is +2. We'll color coordinate here. Second difference equals +0. Okay, so it is a linear function. All right, let's do it again. Okay, so first difference, we want to do our second one minus our first one. So not the bigger one minus the smaller one. We always have to do the second one minus the first one. So 5 minus 7 is -2. 3 minus 5 is -2. 1 minus 3 is -2. -1 minus 1 is -2. All right, now let's do it again. Second difference, so -2 minus -2, so -2 plus 2 is 0. -2 minus -2, or -2 plus 2 is 0. And do it again, it's still 0. So what type of function must that be? Hopefully you said linear. Our first difference equals -2. Our second difference equals +0. So that is a linear function. Now, Mr. Herman, we're doing this, it's just the same thing every time. Well, now it's not going to be the same thing every time. We're doing a little bit of baby calculus. We're not quite doing calculus, but we're seeing some patterns that we see in calculus and what we would do with the calculus stuff, which makes it super cool. Okay, so let's go ahead and just find some first differences and second differences and make some observations. All right, so we'll do some first difference here. Remember, we do the second one minus the first one. So -3 minus 0 is -3. Now we've got -4 minus -3. So -4, we've got to go +3, gives us -1. If you need to use a calculator in some of these, that's fine too. -3 minus -4, so -3 plus 4 is going to give us +1. And then 0 minus -3, 0 plus 3 is going to be +3. So I don't really see a pattern here. I see some 1s and some 3s, some negatives and positives. So maybe there's something to it. But let's find the second difference and see if we can see a pattern. So let's look at second difference. So once again, take the second one minus the first one. So -1 minus -3. So -1 plus 3 is 2. 1 minus -1, so 1 plus 1 is 2. And then 3 minus 1 is 2. Interesting. Okay, so if we look at the pattern here, I don't see a pattern in our first difference in the green, but I do see a pattern in our second difference. Okay, so our second difference is all +2. And that's a cool calculus thing, because that shows us that change that's happening. And we don't have a linear function because we don't have a first difference the same, but our second difference is the same, which means this is a quadratic function. We'll talk more about quadratic functions. This is our first day talking about quadratics, but we'll talk about these for the rest of the quarter and also into next quarter as well. Okay, so that second difference being +2 tells us it's going to be a quadratic function. All right, so let's make sure we get our couple of homework problems done that checks to see how well we understood our lesson today.